Our lesson for this evening is adding and subtracting fractions with same denominator. Same meaning that the same number is on the bottom. First of all, some very important concepts are VICs. We have a fraction. What is a fraction? A fraction is a number that names part of a whole or part of a set. Okay, you might have a whole thing, but a fraction will name part of it. The numerator, there's a numerator and a denominator. The numerator is the top number of a fraction, and it's the part that tells how many parts of the whole that you have. The denominator is the bottom part. That's the bottom number, and this is the thing that represents the total number of parts. It means of all of them together, and then the top number says how many parts that you have. So we have fraction, the numerator, which is the top number, and the denominator, which is your bottom number. One important thing to remember when you're adding or subtracting fractions with same denominators is that only the numerators are added or subtracted. You will never add the denominators. Why? I mean, I've had students that said 1/6 plus 4/6, that must be 5/12. And they say 1 plus 4 is 5, and 6 plus 6 is 12. But it's not 5/12. I'll give you an example why. Here is 1/6. Here is 4/6. If I add them together, 1 plus 4 will equal 5. But notice it's still divided in sixths. It didn't suddenly just split itself in two and divide itself up and make 12 sections. It's still 6 sections. So 1/6 plus 4/6 is equal to 5/6, not 5/12. And remember, these pieces are parts. They always just stay the same. If they're divided in sixth here, they will stay divided in sixth. They don't just suddenly split themselves up into 2 and suddenly now you don't have 6, you have 12. No, it'll stay the same. Now, the same concept is true for subtracting. Let's say I have 4/5 and I take away 1/5. What do I have left? I have 3/5 left, not 3 out of 0. Okay, that's not even a fraction. That's not a possibility. 5 minus 5, we don't do that with the bottom numbers. Only the numerators are added or subtracted. We never do anything with the denominators when they're the same and we add or subtract them. Here's some examples. Let's say that we add 2/7 plus 2/7. All right, here we've got the whole thing divided up into sevenths. 1, 2, 3, 4, 5, 6, 7. And we add 2/7 plus 2/7. And I think we can all see that there's 1, 2, 3, 4 of them that are shaded in. So 2/7 plus 2/7 is 4/7. Notice that the sevenths stay the same. It's not 14ths all of a sudden. It's still sevenths. Let's look at 3/10 plus 4/10. Well, now the whole thing is divided up into 10 parts, not 7 like it was here. 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have 3/10 plus 1, 2, 3, 4/10. How much does that equal? Well, if we look at them all together, 1, 2, 3, 4, 5, 6, 7. You can also think, well, I know that 3 plus 4 is 7. And the answer would be 7/10. not 7/20ths, not 7/20ths, but 7/10ths. Remember that the denominator stays the same. Let's look at some subtraction problems. Let's say that we have 5/9. And by the way, this whole set is divided up into 9 parts. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have 5 of them shaded in. 1, 2, 3, 4, 5. 5/9 minus 1/9 would equal what's left? 4/9. 4/9. Not 4/0. Remember that the denominator stays the same. 4/9. All right, let's look at this. Now the whole is divided up into 13 parts. All right? 10/13 minus 7/13. We might think, well, 10 minus 7 is 3. Put the 3 here. Since this number on the bottom is 13, we write a 13 there. That would be correct. 7/8 minus 2/8. I know that 7 minus 2 is 5. And because 8 is on the bottom, my answer is 8. And so here I've got 5/8. Notice that 8 is on the bottom here. We have 3/13. 13 is on the bottom. Here's 9 on the bottom. All right. So what if the sum, what if you add them together and you get this improper fraction, you get more than 1? That does really bother some students and they're worried that maybe they did it wrong. Here's an example. Let's say you have 4/6 plus 3/6. Well, 4 plus 3 is equal to 7. It could happen like that, 7/6. We usually simplify that. This is called an improper fraction because the numerator or the top number is bigger than the bottom number. So to simplify it, we divide. We always divide when it is an improper fraction. 7 divided by 6. 7 divided by 6. Well, let's see. 7 can be divided by 6 one time. 1 times 6 is 6. Subtract. 7 minus 6 is 1. And we make this remainder into a fraction. And we will say this is 1 and 1/6. So my answer is 1 and 1/6. And I could write it like this. Because 1 and 1/6 is 7/6 simplified. Always divide to simplify when it's an improper fraction. Now, do you have to simplify the answer when you add or subtract? Yes, always. Simplify your answer at the end. That means after you've added or subtracted to get your final answer. For example, 2/8 plus 4/8, 2 plus 4 is 6. However, 6/8 can be simplified. I can divide them. If you remember our lesson from the other day, it can be divided. What's a number that both of these can be divided by? Let's see. It can't be, let's see, that would be 4, that could be 3, but there is a number they have in common, 2. And so we could divide both numbers by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So 6/8 simplified is 3/4, and you would write this 3/4. All right, let's do some try-its here and see how we do. First thing, add. All right, 1/4 plus 1/4. All right, we'll add the numerators. 1 plus 1 is 2. Since 4 is on the bottom, all right, should we simplify that? Yeah, there's a number that both of those could be divided by. We can't leave it like that. What's a number that they both have in common? 2. So we would simplify. 2 divided by 2 is 1. 4 divided by 2 is 2. So we would simplify this problem as 1/2. We would not leave it in the form of 2/4. We would simplify it to 1/2. All right, let's go to the next one. 4/7 plus 5/7. Okay, let's see. 4 plus 5 is equal to 9. And then 7 on the bottom. Can we leave this in the same? No, can't leave this in the same form. This is an improper fraction because the top number is bigger than the bottom number. How do we simplify that? What we'll do is we'll divide. So we'll say 9 divided by 7. Let's see. 9 can be divided by 7 one time. 1 times 7 is 7. Subtract, we get 2. We'll make that into a fraction, 2/7. And our answer would be 1 and 2/7. We would write it like this. We would say 9/7, which is also equal to 1 and 2/7. Let's subtract. 3/4 minus 2/4. Let's subtract. 3 minus 2 is 1. And 4, because there's a 4 on the bottom. Does that need to be simplified? No, because there is nothing that 1 and 4 can both be divided by, and 1 is not an option in this case. All right, let's subtract here. 7/12 minus 3/12. 7 minus 3 is 4. 12's on the bottom. Can we leave it in that form? Should we simplify? Yes. Yes, we should. And actually, if we think about it, what is the largest number that both of these can be divided by? 4 can be divided by 1, 2, and 4. 12 can be divided by 1, 2, 3, 4, 6, and 12. What is the largest number in both lists? Remember how we did that on our simplifying fractions lesson? Well, I see 4 in both lists. So let's divide this number by 4. All right? 4 divided by 4 is 1. 12 divided by 4 is 3. So we would simplify 4/12 to 1/3. And it's okay to write it out. That's one of the steps. It's okay to write it out and say, okay, what is the largest number in both lists? It's okay. That's how we get correct answers. 1/3. Practice problems on your homework guide. Please write these down and solve them in the practice problems section of your homework guide. We'll check them tomorrow. There's 4. Please write them down and solve them. Don't forget to simplify if necessary. We have A, 1/9 plus 3/9. B, 2/5 plus 3/5. C, 5/10 minus 3/10. You've always got to notice your operational symbol because there will be students who will add here. And then the last one, 6/7 minus 5/7. Be sure to write this down, solve it in the practice problem section, and we'll talk about it tomorrow. All right. Hope it was a good lesson. Thanks.